Everything you've been looking at so far is a string. Believe it or not, even if I say set num5 and I say type num, it says num is a string. It's just everything is a string in that particular capacity in Redis. It doesn't care about numbers. It really is just saying, all right, well, that's a string too. It doesn't care. Even though you can do inker num and it's like, oh, cool, that's now a number. That's 6, right? It'll store actually everything as strings. That's totally fine. Strings are binary safe. So technically you could put whole images in here, right? You could have a string, but it's actually really a JPEG. It's fine. Wouldn't recommend it. I'd recommend using something like Nginx for like that, but it's possible. If you needed to temporarily store something in a cache, you could put it in Redis. There are also lists, i.e. arrays, sets, sorted sets, hashes, hyperlog logs. I didn't have a stroke. That's what they're called, hyperlog logs, and streams. We're not going to really be talking about streams. One, they're brand new, and there's not really too much that we could talk about with them. And we're going to really gloss over what a hyperlog log is. I just wanted to say that as many times as I could on air. Okay, let's scroll down here. Why did this get so upset? Okay, let's do some lists first. So a great time to be using a list or an array. Redis calls them lists, but arrays, lists, they're the same thing relatively. Let's say, let's create one. Let's say we're doing an app, and this app does to-do reminders of you or for you. This would be a great time to use Redis, because if you accidentally drop all their notifications on the ground, like you just lose all that data, probably not the end of the world. You just lost some notifications. You still have that source of truth in the database. So let's use Redis for that. So let's say we want to remind our user BT Holt to call his mom, feed the dog, and take out the trash. I'm going to say rpush and notifications, BT Holt, call your mom, feed the dog, and take out trash. There's a non-zero chance that my mom is watching the stream right now, and she's gonna like send me texts like, you better call me. I didn't call her this Sunday, so she's gonna be upset about that one. Okay, so rpush, it's pushing on the right. This is kind of like, you remember queues and stacks and stuff like that, so you're doing like stack.push, right? That's what rpush does. It pushes on the right side or the end of the array. This array doesn't exist, so it will create one on the fly for us. And so now, this says integer 3. That means I successfully pushed 3 things onto a brand new array. And I can say lrange notifications BT Holt. And this is how you do length in Redis. I'm going to say start from 0 and go to the end, which is what -1 is. And this will actually give me back everything that I have in my array at the moment. And it's non-destructive, so if I do it again, it's going to just, it's basically like get for the arrays. And I can do -2. Notice that this doesn't say take out the trash. Or I can say to number 3, right? And this will give me everything because it gives me to the third one. So -1 is the end, -2 is 2 from the end, or 3 is to the third index. Does that make sense? It's kind of a strange way of doing it, but that's the way they architected it. Okay, so let's say we show the notification, take out the trash, to our user Brian, and he's a busy little boy and actually does the things that the notifications tells him to do. We can say rpop notifications BT Holt, and it'll give us back take out the trash. But if we do lrange one more time, now notice that this is no longer in the database, or in our notifications, right? So you can pop things in and out of the list. As you might imagine, we're doing rpop. If you wanted to do shift in JavaScript terms, which who uses that terminology, but a dequeue if you're using normal terminology, or lpop in this, where it's going to remove it from the front of a list. So if Brian does call his mom, we can do this, and it'll say lpop, and we can do lrange again, and now the only thing left down there is feed the dog. You can also do ltrim and rtrim. This will actually take off multiple things in the array, as opposed to pop, which just does one. So that's how you remove multiple things, is with ltrim and rtrim. So that's lists. Let's talk about hashes. Hashes are objects. Like if you've ever worked with Python, they like to call things hashes, or other languages. So they have a thing called HMSet, and we're going to say, let's say we have a BT hold profile, and here you just do key value pairs. So my title, principal, program manager. My title is too long. I can barely spell it. Company, Microsoft, city, Seattle, state, WA, country, USA. Okay, so this is all key values pair. So title will go. The next thing will be the first is the key, then the value, key, value, key, value. And now I can say hget like this, and then I can say btholt profile. So I have to reference wherever that hash is, and then I just ask for whatever I need. Let's say I want to know what city Brian lives in. I can say city, and this will give me back Seattle. So it's all relatively straightforward. It's the same thing. There's hgets, there's hsets, there's hinkers. So all of these commands that I've been showing you have hash equivalents. And then if you want to do hgetAll, bthold : profile, you'll see that it'll give you everything back in key value pairs, right? Title, principal, program manager, company, Microsoft, city, Seattle. It comes back as an array, or a list in this, as it is. Cool. Good so far? There's a bunch more commands that you can do. I'm not going to show you all of them because they're relatively copies of each other, but I left a link there in the course notes for you to see all the different hash commands. Okay, sets and sorted sets. A set is just a group of things, right? So let's say I had a thing called colors. So I can do set add, or sad, as I like to say. I would like to sad colors. And you can just say red, blue, yellow, green, black, pink, brown. Okay, and I just added 7 colors to the color set. And then you can do things like S is member colors green, and it's going to say, yes, I do know green. But I can say, is dog member of colors? And it'll say, no, dog is not member of colors. If I want to see all of the members of it, I can just say S members colors, and this will give me everything that I have in the set. And I can say S pop colors, and it's just going to give me back a random color. So in this case, I got brown back. I don't know if it's necessarily going to be the last one you added. Nope, it's not, because I added black then pink. So it just gives you back a random color. And that's basically what sets are, is you can just keep a bunch of random things in there. Like, I wouldn't necessarily keep every user's email address in there, but you, I guess, potentially could, and say like, well, if you're a part of this set, then I can't let you do something like that. So it'd be good for like allow list, ban list kind of scenarios. So yeah, that would work for that. Sorted sets are relatively similar. That instead of doing sadd and smembers, SAS, you can do zadd, and Z is now a sorted set. So let's do ordinals. And it's kind of like a priority queue, if you're familiar with those, that you give something a priority or like a number. And if you ask for it back, it'll give you back those things in that order. So let's just look at an example of that. So if I add with a priority of 3, third. So key here is the third, and this is the priority, and ordinals is the name of the set of things. Okay, and then I say z add ordinals as in ordinal numbers. That's why I use the term ordinal. One first z add ordinals, two second z add ordinals, 10 tenth. And then I came back and said z range, just like we do with lists, ordinals, and give me all of them. So I, like that. Notice it actually gives them, despite the fact that I had third, first, second, tenth, it actually gives them back to me in the correct order because of these numbers, right? So it's a sorted set. Does that make sense? I'm not entirely sure when I would use this. I guess if I was implementing a priority queue, this would be a good way to implement a priority queue on Redis. So maybe if I was using Redis to order print jobs, might be a good way to do it that way. I don't know why you would use Redis to order print jobs, but that's what came to my mind. Or ordering network traffic, that would be another good reason. Any reason that you'd use a priority queue, this is a way that you could do that with Redis.